Welcome to Continuous Improvement, the podcast where we delve into the world of software architecture and explore ways to enhance our development practices. I'm your host, Victor, and in today's episode, we will be discussing the Command Query Responsibility Segregation pattern, also known as CQRS, and its impact on microservices architecture. But before we dive into the topic, let's take a moment to understand what CQRS is all about. CQRS is an architectural pattern that separates the responsibilities of reading and writing data in an application. Unlike the traditional CRUD approach, where a single data model is used for both reading and writing operations, CQRS divides the data model into two distinct models, the command model and the query model. In simple terms, the command model is responsible for handling write operations, such as creating or updating data, while the query model focuses on read operations and provides optimized data access for queries. So what are the benefits of adopting CQRS in microservices architecture? Firstly, enhanced scalability. By decoupling the read and write operations, CQRS allows for independent scaling of each component. This means that the read and write sides of the application can be scaled horizontally based on their specific demands. For instance, if a system receives a high volume of read requests, the read model can be scaled independently to handle the load without affecting the write model. Secondly, improved performance. CQRS enables the optimization of data models specifically tailored for read operations. Read models can be denormalized or pre-computed to provide faster query responses. Since the query side is designed to serve specific query requirements, it can be optimized for high performance, resulting in improved response times and reduced latency. Thirdly, simplified complexity. As microservices architectures grow in size and complexity, managing data consistency across multiple services becomes challenging. However, CQRS simplifies this task by enforcing a clear separation between read and write operations. Each microservice can focus on its specific responsibility, reducing complexity and making the system more maintainable. Next, flexibility in data storage. CQRS allows different data storage technologies to be used for the command and query models. For example, the write model may use a traditional relational database, while the read model can leverage a NoSQL database or an in-memory cache. This flexibility enables choosing the most suitable storage technology for each specific use case, maximizing performance and scalability. Finally, the ability to evolve and scale independently. With CQRS, the read and write models can evolve independently. Changes to the write model, such as adding new fields or modifying the data structure, won't impact the read model as long as the query requirements are still satisfied. Additionally, as new features or business requirements emerge, individual components can be scaled or modified without affecting the entire system. To sum it up, the CQRS pattern offers significant benefits in microservices architecture. It empowers organizations to achieve enhanced scalability, improved performance, simplified complexity, flexibility in data storage, and the ability to evolve and scale independently. However, it's crucial to note that CQRS adds complexity to the system and should be carefully considered based on the specific requirements of the application. That brings us to the end of today's episode on the Command Query Responsibility Segregation pattern in microservices architecture. I hope you found this discussion insightful and that it will help you make informed decisions when architecting your systems. If you have any questions or would like to share your own experiences with CQRS, feel free to reach out to me on social media. I'm always eager to hear from fellow developers. Until next time, keep improving and building those robust applications.